Okay, so now we're ready to go. All right, so first thing we'll look at is we're going to talk about some definitions of using operations with functions. It's mostly just a notation type thing. So if you see this sort of thing, f plus g of x is how that's read, okay? So it's not just f of x or g of x, it's f plus g of x. What that means is that if you have these two different functions, f of x and g of x, this particular function would be just the addition of those two. Okay, so it equals f of x plus g of x. Okay, we'll do some examples in a minute. Similarly, you can do any other operation. So by operation, I mean addition, subtraction, multiplication, division. You can do any of that. Just like you do with numbers, you can do it all with functions as well. And each one has its own kind of unique notation here. So f minus g of x is what you would expect. It's f of x minus g of x. So you take your two functions and subtract what you have. There's fg of x, okay, which implies a multiplication, so that would be f of x times g of x. And then the division, we got to be a little bit careful because it depends. Because when we start dividing things, then we have problems if we divide by 0. So, but f over g of x would be the same thing as taking f of x and dividing it by g of x. But we have to put a little caveat on here, and just provided that g of x doesn't equal 0. Okay, so for that one, what we might have to end up doing is to actually have a new function, f divided by g of x, we're going to have to restructure what the domain is. So f of x and g of x might have domains that are negative infinity to infinity, everything's happy, but then if we take one and put it over the other one, suddenly we're in the situation now of, oh, I got to check that denominator and make sure that denominator never equals 0. So I got to figure out what x values in g would make that thing go to 0, because now I can't use those numbers anymore. Does that make sense? Because when we divide, we can't divide by 0, so whatever is underneath there, we got to be careful we don't have something that equals 0. Okay? So, let's quickly practice this, and then I really want to focus on compositions for the most part today, so we'll just spend a little bit of time on this. But let's say we've got f of x equals x squared plus 3, and g of x is equal to x minus 5. Those are our two functions we're going to use. So let's see if we can go through and do each one of these operations like we just listed up there. Okay, and then write out a new formula for each one that's as simplified as we can get it. Okay, so f plus g of x, okay, would be taking those two functions and adding them together. Any like terms, put them together. And that's pretty much it. So, can anybody give me the answer to f plus g of x then? Yes, sir.
X squared plus x minus 2.
X squared plus x minus 2. Yeah, exactly. All right, so if we can do that, we can certainly do this. What's f minus g of x? Yeah, go ahead. X squared minus x plus 8. Good, because we're going to subtract the x and we're going to subtract the negative 5, right? So subtracting the negative 5 is going to make it a plus 5, so 3 plus 5 is 8, so we got to have a plus 8. Yeah, good. Okay, How about fg of x? So this one, when it comes to the multiplication, I'm going to be not so much like a hard nose on you have to FOIL it all out and all that. The back of the book, when you check your answers, will do that. They'll actually multiply it all together. So for this one, though, if you wanted to just leave it x squared plus 3 multiplied by x minus 5, that's okay. All right, though, technically, if it were all multiplied together, let's see if I can do all the math in my head here. X to the third minus 5x squared plus 3x minus 15 is what you'd have. Okay, but I'll take either. It's fine. Okay, and then f over g of x. Making the formulas pretty straightforward. Just like the last one, we're just going to put f of x over g of x. So x squared plus 3 over x minus 5 would be the formula then. All right, and so one thing they're going to have you doing with all of these is double checking the domain. Okay, so does the domain stay the same? Does it change? And we can kind of inspect each one of these new formulas one at a time and just ask ourselves what would be the domain for that then. Okay, so the f plus g of x, what do you suppose should be the domain for that? It's x squared plus x minus 2. Yeah, everything still works, right? Negative infinity to infinity. Okay, what about the next one? Somebody who has not spoken yet today. Answer me this. What's the domain? Yes, sir. Right. Yep. Again, nothing wrong, right? There's no dividing, there's no log, there's no square root. So everything still works. Okay, what about the multiplication? Somebody else who has not chimed in yet. What should be the domain for that? So x to the third minus 5x squared plus 3x minus 15. That you've already answered, so somebody else. Yeah, go ahead. You got it. Again, nothing going on that's bad, right? No dividing, no square roots, no logs. Yeah, so it's still everything. It's only when we get to this last one, right? Where things are going to have to change a little bit. So what should be the domain, or at least what should we exclude from the domain in the last one? Yeah. Exactly. Yep. So we can't include the 5. So our domain is going to be negative infinity to 5. Don't forget the union. 5 to infinity. Okay. And that's pretty much it. With the operation stuff, okay, it's just adding, subtracting, multiplying, dividing, formulas together, and then double checking what's the domain when you're done. That's really the process for that. Okay, so compositions. Anybody remember from Algebra 2 what a composition of functions is? Yeah, it's where you put one function into another. Like f of g of x and g of f of x. You guys remember those? Okay. So what we're going to do with these is we'll actually putting functions together that way, and then also evaluating them and checking domains for those as well. So I'll do a quick little definition for this, because there's some notation stuff with this as well. Okay, so it gets written this way, and that little O in the middle there is of. So f of g of x, that's the same thing as this. Which I think is the notation you guys are probably a little more familiar with. F of g of x. And I happen to like the second way better as well, because you can literally see what you have to do. This right here, you're going to take g of x and substitute it into f. And it's even written that way. You got parentheses with g of x in there. Okay. All right, and it can go the other way too. G of f of x. You can do the same thing, but the notation works this way. Okay. So let's say we've got, and I'm going to use some different variables just to keep you guys honest here. So let's say I've got r of x. Okay. And r of x is x minus 1, and maybe we do, v of x is, I don't know, square root of x plus 4, let's say. Let's do some composition work with those two. Okay, so if I do r of v of x, so that means it's going to be r of v of x. So v is going into r. Okay, so maybe we'll just write that underneath v. Oh, absolutely. Yeah. When you're working on it, if you want to just change the notation so it makes more sense, that's totally fine. Okay, so v is going to go into r, and specifically what that means is the entire function v, so that square root of x plus 4, the entire thing is going to be substituted in for x in the first one, in the r function. Okay? So we're going to write out this r of x function, but as soon as we see this x, replace it by this entire function. Okay? So this is going to be the square root of x plus 4 minus 1. And if we so chose, we could go the other way with it too, right? So, whoops, I don't need the or. It's v of r of x. So in this case, we're going r into v. So I take the entire r function, pick it up, drop it into v where the x is. Okay? So we'd have the square root of, now not just x, but x minus 1. So x minus 1, and then we still got that plus 4. Okay, and so this one we can actually simplify up just a little bit. So we end up with the square root of x plus 3 is that composition. Okay, so do we feel comfortable with just the putting it together part of this? Doing compositions. Did I lose anybody there? You did it backwards? Okay. All right. So what I'd like to do next is take a look at some compositions and start talking about domain with them a little bit. So here's a classic one. Let's say f of x is x squared, and g of x is the square root of x. Okay. Now what we're going to do is we're going to think about the domain of these once we're done. Okay. So what we're going to do is identify the domains of these original two functions to start with, because that's going to help us out when we're done. So these are two of your 12 basic functions. We just talked about these yesterday. X squared, what's its domain? Careful. Not range, domain. Yeah, everything works. We can put negative numbers in there, right? No problems. What about square root? What numbers can we put into a square root? Actually, say it again. 0, yeah, 0 to infinity, including 0, right? So 0 to infinity. Okay. So, let's do g of f of x. I'll do the notation this way this time. So if we take f of x, put it into g of x. So that's going to be the square root of x squared, which will simplify to what? Just x. Okay, so domain. Here's the trick. The domain is not always just simply the domain of whatever you end up with. So you can't say, oh, x. I know that function. That domain is negative infinity to infinity, so I'm good. You have to be able to, with these domains, you have to be able to take a number, plug it into the first equation, and then take that answer and plug it into the other one. That's how a composition works as well. So think of it this way. Since it's f or g of f of x, so if I took a number, I have to be able to put it into f of x, and then take that result and put it into g of x. Okay? So I can put any number into f of x that I want, right? Okay? And the result will always be what? Positive. And I can take any positive number that I want and put it into a square root, and I'm still good, right? So, starting at the beginning of that whole process, which numbers can I choose then and have it work? Actually, I can do all of them. I can still do all of them because all I need is the result of this first one to work in the second one. Okay? The output of x squared needs to work into the square root of x. Okay? Because the output of this becomes the input of this. Okay? That's kind of the chain that we're going through right now. So because x squared always gives you something that's non-negative, and anything non-negative is good to go in a square root, the domain ultimately is negative infinity to infinity for this one. Now, there is kind of a trick you can use for that where you don't have to necessarily think that through all the way like that every single time. Though it is good to do that because then you really are seeing what's going on. But what you can do instead is just take a look at this right here, square root of x squared. If you analyze the domain of that before you've simplified anything, it'll work. Okay? So think about this. What numbers can I put into this and have it work? Anything. Anything works right there. So your domain is anything. Negative infinity to infinity. It's going to be a little bit more apparent in the next one. What if we go f of g of x? Turn off your phone. F of g of x would be the square root of x squared, which simplifies to x. Now, let's play this same game again with the domain. I'm starting with g of x. Starting with the square root. So, I have a number to begin with that's going to work here first. What numbers work in g of x? 0 to infinity. Okay? So, I'm already locked into that. Has to be 0 to infinity. Okay? And the result of that I have to be able to square, which I can square whatever I want. So, what should be the domain then? 0 to infinity. Right. Because I have to be able to use those initially. So, again, take a look at this step right here before I've simplified it. Okay? Think domain of this. You see a square root in that problem, right? So you got to think domain of the square root. That's going to do it. Okay? So 0 to infinity. Okay? So like I said, if you're a little confused about trying to follow the whole process, just go here. Just go right there and it'll work. But it's kind of interesting to look at this where you've got two compositions that come out to the same thing, right? X, yet they're technically different. This composition gives you X where it's the entire graph of X. It looks just like the identity function. It's the whole thing. Actually, it would go this way, right? The entire identity function. This result is actually a ray. It's not a line, right? It's the equation y equals x. Half of it starts at 0 and then goes. Okay, so the first composition makes a line. The second composition makes a ray. All right, and so that's why these can be a little bit challenging, is because you can't just look at the result and assume that that's what it's going to look like. Sometimes it's just a piece because the domain gets in the way. So, all right, let's try some other ones. So how about... we'll do f of x equals the natural log, and g of x will be e to the x plus 5. Okay, so let's talk domain of each of these first. What's the domain of the natural log? Yeah. Okay, so 0 to infinity, not including 0 then. What about e to the x plus 5? What's the domain of that? Say it again. Negative 5 is actually still good. Remember, the only three things where we could have problems is when we divide, it's when we have a square root, and when we have a log. If you don't have one of those three things, it's always what? Negative infinity to infinity, because everything should still work. Negative 5 in this one, in particular, if you plug that in, you would have e to the 0, right? What's e to the 0? 1. So you still get a result, right? Still works. So negative 5 isn't a bad number for this one. Okay, so this domain, because it doesn't have one of those three kind of red flags going on, negative infinity to infinity, that's still everything. Okay, so let's try some compositions here. F of g of x. So we're going to dump g into f. So the natural log of e to the x plus 5. Can we simplify that? You guys remember that from Algebra 2? Yeah? Yeah, and so it would make just what is the answer here? X plus 5. Right, it's just x plus 5. Okay, so we got that. Can we identify the domain of that thing, though? So again, go back to before you simplify it. Ignore the natural log for right now. In right here, what numbers can I plug in for x into the e to the x plus 5? Anything, right? Everything still works. Now, when I plug in to an e to the x plus 5, the result is always going to be what? The output of an exponential is always what? Positive. Okay? So I've got a positive number for sure. Not even 0. Can't even be 0. Has to be positive. Okay? Can I do a natural log of that? Yes. Yes. No matter what, right? So what's the domain? Yeah, it's technically negative infinity to infinity. Okay? Because of that e, it's going to turn it positive, so it's always going to work. So any number would be okay still. Okay? But again, if you want to just go to that step before things get simplified, try out the domain of that you can do it that way too. Okay, g of f of x, that's going to be e to the natural log x plus 5. Can we simplify that? This is going to be a little bit of a stretch probably for most of us because it's been a while since we've really looked at properties of logs and exponentials, but maybe we can come up with it. What? You can, but you got to do one step first. Well, I'll help you. I'll get you started here. How about if you have a plus in your exponent, you can turn it into a multiplication problem. So this is e to the natural log x multiplied by e to the 5th. Okay, don't worry about knowing that property for right now. This is just, it happened to pop up in this example, but in general, you're not going to need to know it yet. Okay, but kind of knowing that now, though, what does this simplify to then? Yeah, x times e to the 5th. And e to the 5th is just a constant, right? It's just a number. Okay, if you really wanted to write it as a decimal, I suppose you could, and just leave it as that decimal times x, but that's what it is. Okay, so then what is the domain of this? Can you plug in anything at all? Like the last one? Look at your starting point. Before you simplify anything, right here. Yeah. Right, the first thing you're going to do is take a logarithm, right? When you plug that number in, the very first thing you have to do is take care of this log. And this already has a restriction on it, right? You can only use positive numbers in logs. So, right away, I'm limited where I can only do positive numbers. And from there, everything else is fine. But I gotta stick to that only positive. So this domain has to be 0 to infinity then.
Wouldn't you come to like -4 because you have that +5 there?
It's not, the x plus 5 is not in parentheses. It's the natural log of the number you choose, and then that result plus 5. Yeah. So 0 to infinity is going to be the domain for that. Okay, let's do one more of these together. Okay, just so we can kind of solidify it a little bit, and then I'm going to be done. Okay. So we'll do the reciprocal function this time. F of x equals 1 over x. And then g of x equals maybe like the square root of x minus 3, let's say. Those are the two we'll work with. So each one of these has got its own domain issue going on, right? One involves a division issue, one involves a square root issue. So reciprocal function, who can give me that domain to start off with here? Yep.
-∞ to 0, not including 0. 0, not including 0 to infinity.
Yeah, good. Okay. And then somebody else, what about the square root then? It's the square root of x minus 3. So I always start with this. Can I put a 3 in? Yeah, you can, right? Because it'll just make it 0 and square root of 0 is 0, and that's okay. Can I go bigger than 3?
Yeah.
Sure. Can I go less than 3? No. So what's the domain? Other way. I got it, right? The bigger numbers work, the smaller numbers didn't work, right? So including 3 and up are okay. That's the domain. Okay, so let's try position work here. So how about f of g of x? So I'm going to dump g into f. So 1 over the square root of x minus 3. So that's where I'm at before I simplify. Can I simplify on this one? Not really, right? If I wanted to rationalize the denominator, okay, but it's not really anything you need to do. So we can just analyze it right here. Just see what you got. So what numbers will work in that particular function the way that it's written? Do I include the 3? I can't include it now, right? Because what happens if that square root comes out to 0? Then I'm dividing by 0, and that's a problem, right? So not including 3 to infinity for that one then. Okay, you have to kind of follow it through. What happens if it's 0 and work with that. Okay, the other way, g of f of x. So now I'm going to have the square root of 1 over x minus 3. And can I simplify that thing at all? Not really. Nope. So again, just take a look at what you got, analyze it. What numbers will work in there? Start with the 1 over x. What number is bad there? 0. So automatically can't use 0. Okay. I also have this square root over the whole thing. So the result of this is going to have to be positive or 0. The result of the whole thing needs to be 0. 0 or larger. So this one you might not be able to do in your head. Okay. So here's a little trick you can use sometimes with ones that get a little extra tricky like this one. 1 over x minus 3 needs to be greater than or equal to 0. Agreed? What's under the square root has to be greater than or equal to 0, right? Solve the inequality. Okay? So let's take this the rest of the way. So 1 over x needs to be greater than or equal to 0. Or 3, sorry. Add the 3. Okay, so what values of x would make 1 over x greater than or equal to 3? So including 3 to infinity. So if I plug in a 3, is 1/3 greater than or equal to 3? Does that work? Nope. Yeah, well, the thing is with inequalities, as soon as you start multiplying x's across the inequality symbol, things get screwy. It doesn't necessarily switch. If x is a positive number, it doesn't switch. If x is a negative number, it does switch, and we don't know which it is. So that's a little bit tricky to do. So we're not going to do that. It's better to just kind of think about it right now. So let's start with this. What makes it equal to 3? What value of x makes this thing equal to 3? 1/3. Okay, so something's going on with 1/3. So it's either got to be greater than 1/3 or less than 1/3. Okay, so if I start picking numbers that are bigger than 1/3, like 1, does 1 work? No. Okay, try numbers that are less than 1/3. So like 1/4. Would 1/4 be greater than or equal to 3? Sure. What if I bring it all the way down to 0? Is 0 okay? 0's not okay. Okay, what if I skipped over 0 and went negative? Does that work? No. So where am I locked in here then? 0 to 1/3. Not including 0. Yep. Okay, so my domain then, not including 0, 1/3. Do I include the 1/3? Yes, you can. Yep. That's about as tricky a domain as you're going to get. Okay? I didn't anticipate that one getting that difficult, but you can reason it through that way, but it is tricky. It is very tricky to do. Most of your homework, in fact, I think pretty much all your homework is not going to involve anything quite to that level. One other thing that I wanted to do, just so you have practice doing it, it's pretty simple, but we're going to use this example as a way of doing it. Let's say I wanted to know f of g of, let's do, how about 7? So can you evaluate a composition? Two ways to do it. G of 7, I could go back to my original g of x equation, plug in a 7, and then take the result of that and plug it into f. Okay? Or I can take my new formula I just came up with and just plug it in there and go, which is usually how I do it because it tends to be simpler. So f of g of 7, okay, so here's our equation for that, 1 over the square root of x minus 3. So 1 over the square root of 7 minus 3. So that would be 1 over the square root of 4. So what would be my final answer there for that? 1/2. Okay, then let's say I also wanted to do g of f of, now this one I got to choose something that's between 0 and 1/3, so let's do 1/4. That's between it. Okay, so I have the square root of 1 over 1/4 minus 3. Okay, that's what the number just plugged into the final formula here. Okay, so what is 1 over 1/4? 4. Okay, it's the reciprocal of 1/4, so it's 4. So square root of 4 minus 3, and suddenly it's like, oh, that's easy. What's the square root of 4 minus 3? 1, because it's the square root of 1. So that answer is 1. Okay, so evaluating, pretty straightforward. Okay, stop recording.